The numbers 2 par 2024 and 5 par 2024 are expanded and their digits are written out consecutively on one page. The total number of digits written on the page is very difficult, and I found it a properly challenging question. What I did, I said, hey, let me do 2 par 1 plus 5 par 1. This is 2 plus 5. I'm going to write it as number of digits. 2. I write 2, I write 5. 2 par 2024 is written, 5 par 2024 is written. It's expanded, written down like this. 2 and 5, 22, 2 and then a 5 right equals 2 digits. 2 square and 5 square means 4 and 25. Totally 3 digits will be there. 8, 125, 4 digits will be there. 16, 625, 5 digits will be there. 32, 3125, 6 digits will be there. 64, 3125 into 5, some 15625, 7 digits are there. 128 and whatever this is. I'm guessing there's some pattern. 1 and 1, 2 digits. 2, 2, 3 digits. Cube, 4 digits. Par 4, 5 digits. Par 5, 6 digits. Par 6, 7 digits. Where this goes from 1 digit to 2 digits, this stays as 3 digits to 3 digits. And so it goes from 2 digits to 3 digits. 15625 into 5 will be, it's not more than 100,000. It will be some 78,000 something, 77,000 something. It will stay as 8 digits. 3 plus 5. And so if I had to guess, I would say 2 par 2024, 5 par 2024, 2025. Done. I'm taking a punt. I know we're taking a chance. This is what it turns out to be. Very happy. And so, but hey, we can't just do that. We say, hey, how do we do this? Fine. So we say, let me do log of 2 par 2024, log of 5 par 2024. Nice. Both to the base 10. Then we'll think about what this becomes. Log 2 is 0.3010. Log 5 is 1 minus this. Log 2 plus log 5 is log 10. Log 10 is 1. So I can find out this log approximately. What is this going to be? What is that going to be? And then find out the number of digits. And that's a different approach for doing this. Very interesting approach. Right? So there is something very juicy sitting inside this. Well, I don't know log 2. What is this? And so this is 2024 times log 2 to the base 10. This is 2024 times log 5 to the base 10. Nice. So suppose log of a number where 1.6, a number lies between 10 and 100, 2-digit number. Log of a number where 2.2, number sits between 100 and 1000, 3-digit number. If log k is 21.6, then k is a 22-digit number. Nice. Very simple idea. Because log 10 square is 100. 10 cube is 1000. So 10 par 2 point something will be between 100 and 1000, 3-digit number. Any 3-digit number, its log will be 2 point something. Nice. So now log 2 to the base 10, if I call it x, log 5 to the base 10 will be 100 minus x. So 2024 times x, 2024 times 100 minus x. Right, so this number 2024 times x, suppose this starts with say n point something, it will have n plus 1 digits. This side 2100 minus, not 100 minus x, 1 minus x. This will be 2024 minus 2024x. If this starts with n, it will be 2024 minus n, whatever, we can simplify that. Think about this. if this starts with n point something, this will have n plus 1 digits. That number will have 2024 minus n digits. Write down both. 2025 digits totally. Excellent, excellent, beautiful question, using the idea that if take log of a number to the base 10, if log of a number to the base 10 is 2 point something, it has 3 digits. Log 100 is 2, log 1000 is 3. Log of a number between 100 and 1000 is 2 point something. So if a log of a number is 2 point something, it has 3 digits. Log of a number is 6 point something, it has 7 digits. Log of a number is 9 point something, it has 10 digits. You take this and this, total number of digits will be 2025. It could so happen that this has, I don't know, 680 digits, that has the remaining. But the total number of digits will be 2025, which is why this idea worked. Our trial and error, let me just have a feel for it, let me have a go at it, that worked. Because of what is sitting in the idea that log 2 to the base 10 plus log 5 to the base 10 is 1. Beautiful question.